Good morning, students. I am Vikram Singh Rathod, Assistant Professor at Center for E-Governance. Today, I am representing the clustering using mean shift algorithm in machine learning, and our previous lecture is K-mean algorithm in machine learning, and today we discuss the mean shift algorithm. Basically, the difference between the above algorithms are discussed here. Uh, it is another powerful clustering algorithm used in unsupervised learning. Unlike K-means clustering, it does not make any assumptions. In K-mean, we make assumptions, and in this mean shift, we does not require any type of assumptions. Hence, it is a non-parametric algorithm. So that's why mean shift algorithm is a non-parametric algorithm based machine learning program that is I am also defining in our next slides. And the mean shift algorithm basically assign the data points to the cluster iteratively by shifting points towards the highest density of the data points such as clustered centroid. In our previous lecture, I am also defined the cluster. A cluster is a similar type of data points or a data base and entries. Those are similar is called cluster, and centroid it means the cluster is defined in a particular form in a circle for defining itself as a cluster. So I am also describe the program in you can notice that the difference between k-mean algorithm and mean shift algorithm is that latter one does not need to specify the number of clusters in advance because the number of clusters will be determined by the algorithm or WRT data. Working on mean shift algorithm, we can understand the working of mean shift clustering algorithm with the help of following steps. The steps those are used to defining the mean shift algorithm in defining our next slides. So those steps are 5 steps that are used in mean shift algorithm. First of all, we start with the data points assigned to a cluster of their own. It means we assign the data points to a particular cluster, and the next step is the algorithm will compute the centroids, and the algorithm define the centroids or the data points those are collected in a centroid. And the third one is in this step we define the location of new centroid will be updated. In this concept the new centroids will be make, and we can also update the data points also through the mean shift algorithm. And the next fourth one is the process will be iterated and moved to higher density region. So in this step 4 we follow the iteration of the concept of the ML using 4 language of Python or R language, that is define the for loop or iterative concept to move the data points to high density region. And the next or last one step is step 5th. It will be stopped once the centroid reach at the position. When the centroids or data points are satisfy the condition, then it automatically stop the data points those are defined in a particular cluster. Then after I am representing implementation of mean shift algorithm in Python. It is simple example to understand how mean shift algorithm works. In this example, we are going to first generate 2D dataset that contain the two-dimensional dataset and containing 4 different blobs. Blobs are here also called clusters. After that, we will apply mean shift algorithm to see the result that we want or predict. So I am defining an example here. First of all, we import the NumPy library for the mathematical calculations, and then after from sklearn library import clusters and also import mean shift that is defined in sklearn library, and then import matplotlib .pyplot as plt. Matplotlib is a library that is used to define the data in a visualization form, so we can use its method pyplot as a alias name plt, and then after from matplotlib import style that is used to define the colors or the names or legends of the data that is defined in a graph. Then after style.use ggplot is also called from the matplotlib style library, and then after I am also describing sklearn library and then called datasets. Here the dataset is a database that contains the samples underscore generator. It means the values those are stored in the sklearn dataset library, and then import make blobs, and then after I am defining a variable centers and describing the data as a list like structure, putting some arguments such as 3 3 3 and 3 5 5 and then 3 10 10. Basically it's retrieve the number of the values from the data set that is used by in our program. Then I am describing the x and underscore variable make blobs, and then putting 4 arguments such as n samples is equal to 700 and centers is equal to centers and cluster underscore std is equal to 0.5, and then after I am plot or scatter the data that is generated or get from the various library. So I am define plt dot scatter method and put the axis of the values as x-axis as a 0 and x-axis as a 1, and the last statement plt dot show, it is used to create the data in a visualization form as per describing the variable centers values. So you can easily understand the some data points or the are describing in this slide. You notice that the x-axis and y-axis corresponding values of the data points. Here the 3 clusters or blobs are describing through our code. I am also execute the above code in my laptop. You can also use this code for implementing or executing the above program. You can also notice that as per the previous slide diagram, our result is also defining here as a output of the above program. So you can easily use the code or see the code and execute the code as per your convenience using Anaconda environment through various type of tools provided by Anaconda, Spider, Jupyter, Visual Studio Code, etc. As per you can wish, you can easily execute the programs. Then after I am also defining the mean shift algorithm, another example for creating the data in a various colors or labels or marker size. Those are defined in this example. So first of all, I create a variable ms is equal to mean shift method, and then after I am fit the values in ms. So I put here ms dot fit and put the argument x, and label is equal to ms dot label underscore cluster underscore centers is equal to ms dot cluster underscore centers. Those are the values defined in mean shift. I am defining it. Then print cluster centers, and then after I am create a new variable n underscore cluster underscore is equal to len method, that is count the length. So at this time I am use the numpy library alias name np dot unique labels. So it retrieve the unique labels from our data set that is used in our program. Then after I am defining a message in a program, so I write the print statement estimated clusters into inverted comma, and then define a comma and put variable n underscore cluster, that is the calculating the length of unique labels. Then after I am defining the colors is equal to 10 into various type of color legend attributes such as R, G, B, C, K, Y, M. Those are the color regarding attributes names. And then after I am defining a for loop. In this loop I am defining a I, or in the range len, that is defined by the len method of np, and put x as a variable, and as per the for loop I am close the bracket and put the colon. And then after in for loop I am defining a statement plt dot plot and defining the various arguments. Those are plotted in our result. So I am defining the axes or colors or marker size in the loop. So x as a ith and 0th index, and x ith and first position of the index, and color labels is equal to ith, such as RGB execute as per defining the colors. And marker size, it means the size of the data point is 3 cm. And then after I am defining the plt dot scatter method. In this method I am use cluster underscore center variable and put the values colon 0, and cluster underscore center colon and put the value 1, and then defining the marker is equal to inverted comma and put the dot, and then color is equal to k, and s is equal to 20, and the line width is equal to 5, and Zorder is equal to 10. So basically it define the visualization data. Those are used to make the diagram of the data points, and then after the last statement is used to draw the graph or graphical representation of the mean shift algorithm using various data points or blobs. Those are used in our database. So defining plt.show method, and after executing it provides some values of the data points. Those are defining as per the coding, you can notice that. And the estimated clusters is equal to 3. Basically 3 clusters are created using the above code, and the values those are accordingly defining in the brackets or in a list like structure. And you can also notice here there the three blobs or three clusters are making in various type of colors such as blue, green and red, and three dot points also define the three centroids or blobs, and defining x-axis as the values 2.0, 2.5, 3.0, 3.5, 4.0, 4.5 and 5.0. You can also notice in our practical approach of anaconda spider, you can notice, and y-axis hold the values of the x-axis from 2 to 10. You can notice here the example code that is run, and as per previous slide you can see the output in this slide. I am using spider for writing the code for mean shift. You can notice that the three colors blobs or centroids are created, and some values are also defining here the right side in the slide. And then after I am also describing the advantage and disadvantage of the mean shift algorithm. So first of all, I am defining the advantage of mean shift clustering algorithm. The first advantage, it does not need to make any model assumption as like in k-means or Gaussian mixture algorithm. So it cannot based on the assumptions. And the second one advantage, the model, it can also model the complex cluster which have non-convex shape, can easily be draw or put as a output showing in visualization shape. And the third one, it is only need to one parameter named bandwidth with automatically determine the number of clusters. And the fourth one is there is no issue of local minima or minimum as a like in the k-mean algorithm. And the fifth one is there is a no problem generated from outliers. And the disadvantage is also describing here the mean shift. The following are some disadvantages of mean shift clustering algorithm. The number one is mean shift algorithm does not work well in the case of high dimension, where number of clusters change abruptly. And the second one, we do not have any direct control on the number of clusters, but in some applications we need a specific number of clusters. So we can't define the number of clusters in the mean shift algorithm. And the third one or last one is it cannot differentiate between the meaningful and meaningless model. And our next lecture is defining on the machine learning, also on the unsupervised algorithm of the k-mean, that you can also see in our next lecture. Thanks, students.